Hello, welcome again to our YouTube channel. We are the Fatima Institute. So, today we are going to learn advanced aspect of financial management. And the advanced aspect of financial management, we got the financing decision is one of the most examinable and most important topic in here. And the financing decision, we have the IOS schedule. That is the investment opportunity schedule. Under this, we compare the IRR and the MRR. And if the MRR, the marginal cost, is higher than the internal rate of return, we ignore the project or we just reject the project. But if the internal rate of return is higher than the MCC, we undertake the project because it will be of use to us. It will bring it will have a positive feedback to the investors. So under this topic, we learn about how to start by depleting the cheapest source of finance, followed by the more expensive source of finance, and then followed by the most expensive source of finance. Today, we are going to tackle a question that was examined in May 2017 as question 1B. So in this case, we are going directly to the solution. You all got the past papers. Or if you don't have, you can download the CASNEP app. So the solution, we start by in this way of starting with the cheapest source of fund to the most expensive. Basically, the cheapest source of fund is retained earnings. The second cheapest is debt because interest on debt is tax exempt. That makes it cheaper. And then the most expensive is equity because equity you will have to dilute even the ownership of the business, because the moment you sell the shares you will earn equity, yes, but you will have diluted the ownership of the business. So basically we start by depleting the retained earning. In our case, we had a retained earning of 2.5 after tax. This retained earning, we were told 40% was retained and 60% was paid out as dividends. Is that okay? So you come, you say the retained amount was 40% times the 2.5. That is the amount they had. So they have first of all to distribute the dividend, so they are left with the retained earning. So in that case, you get retained earning as 1 million Kenyan shillings. So we first of all begin with exhausting that, and then we follow the next most expensive form of equity. That is, we follow the pecking order theory. So from the retained earning, we have to calculate the break point. We said retained earning under debt and equity, retained earning is equity. And we were told the debt to equity ratio is 0.45 to 0.55. To get the break point, you take the amount of retained earning, the 1,000 we computed up there, and then you divide by the equity ratio, the 0.55. You get shillings 1,818,182. And then after depleting that, we start with the cheapest debt. We are told the company can raise debt up to 500,000 first. So the first break will occur at 500,000. It will be the cheapest. So being that it's debt, you take the ratio of debt, the 0.45. To get the break, you get 500,000, you divide by 0.45. You get 1,111,111. And then we go to the second cheaper debt. The second cheaper debt, we are told up to 900,000. So you take the 900,000 again, you divide by the 0.45, you get the break point of the second cheapest debt. That is 2 million. Is that okay? And then we are told above 900,000, there is no break because there is no any other limit. Any amount raised above 900,000, there won't be any break because there is no limit to that. Then after depleting the debt, we go directly to equity. Are we together? In equity, that is how much we can raise externally. How much we can raise externally from maybe the sale of shares and such. So the cost of equity, we all know the formula. The cost of equity, we say it's D naught, the dividend paid, and then if there's growth, you have to multiply by 1 plus D, that is 1 plus growth. You divide by the market price prevailing, and then you minus flotation cost. If there's any flotation cost that will be incurred to raise that amount of capital, and then you have to add growth. So basically the formula, it will be KE is equals to D naught 1 plus G over P naught minus flotation cost, and then the total you add the growth, and then you multiply by 100 to make it percentage. So in our case, it will be, we were told they paid dividend of 2.2 per share. So you take the 2.2 and then you take 1 plus growth. The growth is 0.05 in our case, over the market price of issuing this, of raising this capital, it's 22. And then they are incurring a flotation to raise this capital of 2.2. So the flotation, that is, you take the 22, the market price minus the flotation, and then you add the growth 0.05. You multiply by 100. In that case, we get 16.67. That one is the cost of raising the equity, 16.67%. And then the cost of raising the retained earning, basically, it's the same as that one of equity, only that we won't incur any flotation cost. So you apply the same formula. You apply the same formula you used up there, but you eliminate the flotation cost. In that case, we'll get 15.5%. I hope you are all getting. The next point, we take the debt and equity, and then the WACC. The debt equity ratio was 0.45, and that was for the debt, and then for the equity was 0.55. And then the limits, tuliona the first break in our count was 1,111,111. That is between 1,111,111. That is the first break. That is the first limit in breaks. So in that case, unakaa unaangalia debt ilikuwa gapi. And the debt, we said for the debt, we got 6.3%. Is that okay? So you take the 6.3, and then for equity, we said equity at that level, it will be 15.5 because it will just be the retained earning. In the next part, we have between 1,111,111 to 18,182, as we calculated before. For the first debt, it was adding up to 18,182. So for the second debt, tunakuja tunaangalia aje which was the rate for the debt. For the debt, we got 7.7. This 7.7 is for the debt. So for the equity still remains as that one of the retained earning, that is 15.5%. And then we see the third break, it was occurring at 2 million. At 2 million, you take between 18,182 minus add up to 2 million. Is that okay? And then you get the percentages of debt and equity. And then above 2 million, there is no break. So you calculate the WACC. WACC will be given by the debt for the first break was 0.45 multiplied by the debt. So it's KEWE plus KDWD. Because in this case, we assume that there is only debt and equity. There are no preference shares here. So the WACC will get KEWE plus KDWD. That is the weight of equity multiplied by the weight of equity multiplied by the cost of equity plus the cost of debt multiplied by the weight of debt. In that case, after you sum up all of them, you get the percentages for each of the units. These percentages are the ones you use in the IOS graph. So to calculate IRR for project A and C, we were given the IRR of the rest of the projects, but we were not given that one of A and C. We assume that NPV here is 0. Is that okay? So NPV is given by PVIF. If at all it's for annuity, you have to include the annuity. So it's the present values interest factor of annuity multiplied by the rate at the number of years, and then you minus the initial capital outlay. In our case, we are looking for IRR. The IRR will be given by, that is the rate. It will be given by, you have the initial capital outlay for each project. So precisely for project A, we got 675,000 is the initial capital outlay, and then we have the annuity as 155,401. So to get the present value interest factor Rn, we get from the table. The N is 8 years, and then 8 years and 8 years and a percentage of. We are now looking for the rate. We got this 4.3436, and then we are looking for the rate. So you'll take the 4.3436, you look from the tables with the 8 years, N is 8, and then you'll get 16%. So the IRR for A is 16%. And then for project C, you will get the same, the initial capital outlay of C, you divide by the annuity of the project C, and then you take at N being 4. So we get 2.3216, and then from the tables with the N as 4, you will get it as 14%. Is that okay? And then for IRR, we organize from the highest, and then we cumulate the amount to get the cumulative amount to use for the IOS schedule. So in our case, the highest IRR was for project A, that is 16%. For project B, it was 15%. For project C, 14%. For project D, 12%. And for project E, 11%. And then we take the cost of each project, the initial capital outlay, and then we cumulate the cost. And then this cost will be the one to be used in the IOS schedule. So in your IOS schedule, we normally cumulate the funds. The cumulative funds are on the vertical line. On the horizontal line, we have the IRR and WMCC, the weighted marginal cost of capital stroke the internal rate of return. Whichever project that the WMCC will be higher than IRR, we should reject them. So in our case, when we draw the graph will be attached down there. So if we draw the graph, project A, B, and C, IRR is greater than WMCC, and we should accept the project. Do you know why? The internal rate of return of this project is greater than the cost. WMCC is the cost of raising the additional capital. So if at all the cost is greater than the IRR, we should reject. And in this case, for project D and E, the IRR is less than WMCC, so we should not partake the project, we should reject them. Therefore, we should accept all the project those are above the WMCC curve. Thank you for your time, students. I'm glad. See you again, and make sure you revise on this. It's a very, very examinable topic. Thank you. Until we meet again. Bye bye. Make sure you like, subscribe, and share. We'll be communicating more and more in this platform.